Hey guys, and welcome back to another video on my YouTube channel. This video is all about the sine rule. So let's get started. Before we go on the calculating parts, let's first see what the sine rule is. The sine rule helps us calculate unknown side lengths or angles in triangles that aren't right-angled. I'm showing you the sine rule here. The capital letters A, B, and C are angles here. The lowercase letters A, B, and C are the sides opposite to the angles respectively. In other words, the lowercase a is the side opposite to angle AE. The lowercase b is the side opposite to angle B, and the lowercase c is the side opposite to the angle C. As you can see here, the sine rule says that in any triangle where the angles are AE, B, and C, which are shown here as the capital letters, side AE over sine of angle AE equals side B over sine of angle B, which also equals side C over sine of angle C. The sine rule can be applied when you know any pair of opposite sides and angles in a triangle. For example, like in the triangle diagram I've shown here. As I'm showing you here, to find a missing side length of a triangle, this formula is used, the same one I showed before. To calculate a missing angle of a triangle, you can rearrange the formula for missing side length and use the version I'm showing here. If you apply the sine rule to a triangle with two sides and an angle that isn't between them, it's possible that more than one triangle could be formed. The side opposite from the angle given can have two different possible positions. This can result in two possible values for each unknown angle and two possible lengths for the side that's missing. The two angles located opposite the side given will sum to 180 degrees. The sine rule will always provide the acute angle, but you can determine the obtuse angle by subtracting it from 180 degrees. Sometimes, the obtuse angle may not be valid since it could result in the sum of the triangle's three interior angles being more than 180 degrees. The question will usually say if the angle you need to find is acute or obtuse. Here's an example. Over here, we need to find y and z. As you can see, in order to find z, we need the value of angle B. To get the value of angle B, we first need to find y. So, it is reasonable that we start by finding the value of y first. So, using the rearranged formula version to find the angles, we substitute the values into the formula. Sine of y over the length of the side opposite to angle y, 13.1, equals to sine of 25 over the length of the side opposite to the 25 degrees angle, which is 9.2. Then solve for y. Multiply both sides by 13.1. Then take sine inverse of everything on the right side of the equation. Now we input all that into our calculator and press equals to. I have already explained how to get the sine, tan, cos and their inverse functions on a calculator in my previous video on trigonometry, so katoa. You can refer to it if you do not know how to get the sine, tan, cos and their inverse functions on a calculator. Moving back to our answer, we get a pretty long value on our calculator. So, rounding it to three significant figures gives us 37.0 degrees as our final answer. Now, let's move on to find z. In order to find z, we will use this version of the formula here. So, substituting the respective values in the formula, we get z over sine of angle B equals to 9.2 over sine of 25. As you can see, we need the value of angle B to proceed further to find z. To find angle B, we know that the sum of the total angles in a triangle is 180 degrees. That means that 25 degrees plus angle A, which is y, plus angle B, equals to 180 degrees. Note that we will use the longer value of y here. Now, we have an equation which we can solve to get the value of angle B. So, adding 25 and the longer value of y gives us another long value, 61.9968, and so on. Then, we subtract the new long value from both sides to get our value for angle B, 118.0031, and so on. This is also a pretty long value, but we don't need to round it off to three significant figures. We will use this long value for angle B for our calculation further. Now we can proceed with finding the value of z. First, we substitute the long value for angle B into the formula, which is 118.0031, and so on. Then, we multiply both sides by the sine of the long value of angle B. Entering 9.2 over the sine of 25 multiplied by the sine of 118.0031, and so on into our calculator, we press the equals to button and get a pretty long value as our answer again. Rounding it off to 3 significant figures, we get that our answer for z is 19.2 centimeters. Thanks for watching. If you have any doubts, please comment below and I'll clear them for you. Please like and subscribe. I'll be sure to post another video soon.